Question 1. What is the degree of each monomial? So remember, the degree of a monomial is found by taking the sum of the exponents of the variables. So in this case, we are looking at taking 3 plus 7 plus 4, which gives us a degree of 14 when we add them all up. For question 2, same idea. We're going to take the sum of the exponents, so 6 plus 3 gives us a degree of 9. Questions 3 and 4, we're looking at the sum or difference for adding or subtracting monomials. So in both cases, so in question 3, we have 2x to the 6th plus 3x to the 6th. We have like terms since they have the same variable and the same exponent. So the only thing we need to do is add the coefficients. So our answer becomes 5x to the 6th power. In question 4, same idea. We have the same grouping of variables with the same exponents. So all we're going to do in this case is subtract our coefficients. And 5 minus 7 is negative 2, x to the 3rd, y squared. In 5 and 6, we're looking at adding and subtracting polynomials. So ideally, we're looking to combine like terms. So in 5, we look for our like terms. We've got 7b squared and the 6b squared. So 7 plus 6 is 13b squared. We only have one b term, so we take plus 9b. And then we have 1 8, or one constant, so we put plus 8 at the end. So our answer is 13b squared plus 9b plus 8. In question 6, we want to combine like terms, but before we do, since we have subtraction, we're going to distribute this subtraction to the second quantity. So it changes our problem. We've got 3m squared plus 2m minus 8 minus 4m squared plus 5m minus 6. Now we want to combine like terms. Well, we've got 3m squared and negative 4m squared. That gives us negative m squared. We've got 2m and 5m, so that is 7m. And we've got negative 8 and negative 6. Well, that's negative 14. So our answer is negative m squared plus 7m minus 14. Questions 7 and 8, we're looking at simplifying the product, so we're multiplying. And in this case, we're distributing. When we distribute a monomial throughout the polynomial, remember, we're going to multiply coefficients and add exponents. So 3n times 4n squared, we get 3 times 4, which is 12, and we add the exponent, so we get n to the 3rd. Then 3 times 5, well, that's 15, and we add the exponents on our variables. Question 8, same idea. We're going to distribute the 7y to the 3rd throughout the polynomial. So negative 7 times 4 is negative 28. Y to the 3rd, y squared becomes y to the 5th. Negative 7 times 1 is negative 7. Y to the 3rd and the y to the 1st becomes y to the 4th. And then last but not least, negative 7 times negative 3 is a positive 21, y to the 3rd. In 9 and 10, we're looking to just find the greatest common factor for each polynomial. So in number 9, I know that 44, one of the ways to make 44 is to take 4 times 11, and one of the ways to make 33 is to take 3 times 11. So that tells me right off the bat that 11 is probably the GCF of my coefficients. And then I look for my variables. I have x squared next to the 4th, so I can take at least an x squared from every term. So my GCF is 11x squared. Question 10, same idea. I'm looking to see if I can figure out what makes up each of the terms. So 9, 3 and 3. 21 would be 3 and 7. And then 39, well, that's 3 and 13. And so in this case, the only number they have in common is 3. And so I know that my GCF coefficient is 3. And I look at my variables, and I can take at least an x squared from every term. And so my GCF for 10 is 3x squared. In 11 and 12, this time I'm looking to factor using the GCF. So I have to figure out what the greatest common factor for 48 and 30 is. Well, I happen to know right off the bat that 6 is the greatest common factor of 48 and 30. And then looking at my variables, I can take a w to the 6th from each one. And so I'm going to factor those out. When I factor these out, I'm going to divide the coefficients, so 48 divided by 6 is 8, and subtract the exponents on the variables. So 9 minus 6 is 3, and then 30 divided by 6 is 5, 6 minus 6 is 0, so those cancel out. And this is my factored form. I'm going to do the same thing in 12. I know that 9 goes evenly into 54, so 9 has to be my GCF. And then I look at the variables. Well, I've got c to the third and d squared here. And so I can take out a c to the third and d squared. And I'm going to factor these out by dividing the coefficients and subtracting the exponents. 54 divided by 9, 6. The c to the thirds cancel, and I'm left with d squared for my d variable. And then 9 divided by 9 is 1. 4 minus 3 is c to the first, and the d squareds cancel, so this is my factored form. So in 13, we're looking to use FOIL or crab claw to multiply the two binomials. So in 13, we take 3h times 3h, which is 9h squared. We get 3h times negative 6, which is negative 18h. Negative 7 times 3h, which is negative 21h. And negative 7 times negative 6 is a positive 42. The last thing we need to do is combine like terms in the middle here. And we get 9h squared minus 39h plus 42. Question 14 is the same. We're going to use FOIL, so negative 4h times 3h is negative 12h squared. Then negative 4 times 7 is negative 28h. And then 2 times 3h is 6h. And 2 times 7 is 14. We're going to combine like terms in the middle. We've got negative 12h squared minus 22h plus 14. In 15, we've got j plus 7 times j minus 7, so we'll use FOIL again. J times j is j squared. J times negative 7 is negative 7j. 7 times j is a positive 7j. And 7 times negative 7 is negative 49. In the middle, we have like terms, so we're going to combine those. In this case, negative 7j and positive 7j cancel out, and we're left with j squared minus 49. Continuing using FOIL, 3x times 2x is 6x squared. 3x times negative 6 is negative 18x. 4 times 2x is 8x. And 4 times negative 6 is a negative 24. In the middle, we want to combine like terms. We've got 6x squared. Negative 18x plus 8x would give us a negative 10x. And then we've got negative 24. Question 17. You've got the quantity 2x minus 6 squared. Remember, when it looks like this, you need to rewrite it as 2x minus 6 times 2x minus 6. So that way you can use FOIL. And so now we'll FOIL this out. 2x times 2x is 4x squared. 2x times negative 6 is negative 12x. Negative 6 times 2x is negative 12x. And negative 6 times negative 6 is a positive 36. Negative 12x minus 12x is a negative 24x. So we end up with 4x squared minus 24x plus 36 as our final answer. Question 18, same idea. We're using FOIL. 4p times 4p is 16p squared. 4p times 8 is a positive 32p. Negative 8 times 4p is negative 32p. And negative 8 times positive 8 is a negative 64. So in the middle, we're looking to combine like terms. We've got 16p squared minus 64, because our middle terms cancel out. A positive 32p and a negative 32p just cancel out, and you're left with 16p squared minus 64. All right, last two problems for this part. We've got question 19, which is the quantity 4n minus 5 times the quantity 2n squared plus 5n plus 3. We're going to use the distributive property here. So we're going to distribute 4n throughout the entire quantity and then distribute the negative 5 the same way. So 4n times 2n is 8n cubed. 4n times 5n is 20n. 4n times 3 is 12n. And then we distribute the bottom, or we distribute the negative 5 throughout the bottom. So negative 5 times 2n squared is negative 10n squared. Negative 5 times 5n is negative 25n. And negative 5 times a positive 3 is a negative 15. So our last step is to combine like terms. Well, I only have one n cubed, so I can take the 8n cubed and bring it down. I've got 20n squared and a negative 10n squared, which when I combine like terms, I get a positive 10n squared. And then I've got 12n and a negative 25n, which gives me negative 13n. And then I bring down the negative 15 at the end. And this is my answer. I will take a similar approach to solving question 20. I'm going to distribute 4k to 3k squared. I get 12k to the third. I go 4k times negative 4k, which is negative 16k squared. I've got 4k times negative 4, which is negative 16k. And then I distribute the 5, so that's 15k squared. Then I've got 5 times negative 4k, which is negative 20k. And then 5 times negative 4, which would be negative 20. Kind of ran out of room here. So now I just need to combine like terms. Well, I only have one k cubed, so I take 12k cubed, bring it down. I've got negative 16k squared and a positive 15k squared. So that's a negative k squared. I've got negative 16k and a negative 20k, which is negative 36k. And I bring down the negative 20 at the end. And this is my answer.